Good afternoon, everyone, and welcome to the first day of the Pennsylvania Automated Vehicle Summit. Today is the Automation and Technology Day of the conference. My name is Mark Kopko, and I'll be moderating the first session. For anyone who doesn't know me, I am the Director of the Office of Transformational Technology here at PennDOT, and I oversee our automated vehicle program here for the Commonwealth. I would like to thank you all for taking time to listen to the fantastic speakers that we have in today's lineup. We would now like to make a special point of thanking our platinum sponsors for the whole conference here, HNTB, Locomation, and Michael Baker International. I would also like to thank today's gold sponsors, Gannett Fleming and Stantec. And finally, I would like to thank our silver sponsor, Kimley Horn, for sponsoring today's Pathway to Deployment breakout, which we encourage people to listen into here. And we thank our many sponsors whose contributions have helped make this event possible. Few housekeeping items here before we begin. So you're all aware this session is being recorded and we will be made available to attendees later this year. You will also see that your microphone has been automatically muted and reduced to help reduce the background noise. So please feel free to use the chat functions on the right-hand side of your screen for general conversations and comments, and then most importantly, the Q&A section to ask questions about the presentation and upvote the questions that you would most like to hear answered. So just make sure to enter that in. Click that up like if you see a question that you didn't enter personally, but you would like to see answered, and we'll try and make sure that we get to those questions. During today's discussion, I'll be pulling questions exclusively from that Q&A section. So if there's any questions that are posted in the chat, we may miss them. So please, once again, just use the Q&A section. So, the secretary did the welcome. She apologizes due to another scheduling conflict. She wasn't able to make it, but felt it was important to actually do an opening message here and show the importance of automation to the department. And with that, I would like to invite our distinguished speaker begin this presentation. So up first, we have Tekin Mericli, who is the CTO and co-founder of Locomation. Full bios for Tekin and all the other speakers are available on the Summit's program and on the Summit's website. So with that, Tekin, I will turn it over to you. Thank you.
Thank you very much for the introduction, Mark, and thank you, PennDOT, for your kind invitation and considering me for this keynote speech. So let me very quickly. All right, make it full screen. So thanks again, everyone, for attending this talk. Today I'm going to be talking about Locomation, our approach, who we are, what we do, and why we do it that way. It's going to be a relatively broad presentation. So feel free to drop your questions, and I'll do my best to answer them at the end of the talk. Maybe a little bit of introduction for myself. I'm one of the co-founders and CTO of Locomation. Prior to Locomation, I was at Carnegie Mellon's Robotics Institute, and particularly at this semi-autonomous applied R&D division named the National Robotics Engineering Center. And essentially, my day job was building autonomy systems for different problems. They may have originated from Department of Defense or from the industry like mining and agriculture. And our job was to come up with clever solutions to those tough problems. So maybe with that, I can also kind of provide a 30,000 feet overview of Locomation. We founded Locomation in 2018 as 5 co-founders from NREC, Carnegie Mellon's NREC. We are a relatively small team, a boutique team, if you will, but a very strong one. At the moment, we are about 77 people, and we have a relatively small amount of funding compared to all the AV craze going on nowadays. But as I said, because of our dance experience, we know how to actually stretch those dollars. We are based in Pittsburgh, PA, but we also have a permanent garage space at the Transportation Research Center in Ohio that we use for high throughput closed track testing. We recently actually moved our offices to the famous Robotics Row in Pittsburgh. So if you are in town, please reach out to me and I'll be more than happy to host you in our facilities and show you around. So we started Locomation as 5 co-founders, 5 roboticists. And of course, from day one, we knew that this was a team play. It would not be just us as technologists going to our corners and building technology in complete vacuum and isolation and hoping that it would be magically integrated into the industry. So that's why we had to also surround ourselves with experts from different fields, including, of course, trucking, as well as overall automotive and safety, systems engineering, regulations. So we have a super strong team. Maybe a little bit of statistics on the left side. Just among the 5 co-founders, we have more than 100 years of collective experience in developing autonomous vehicle solutions. And when it comes to trucking-related technology development and sales, we have more than 70 years of experience. Again, safety is super important for us, making sure that whatever we are building is super safe. And we have quite a bit of experience on that front as well. And again, on the technology end, not just the 5 co-founders, but our overall engineering team comes with, on average, 14 years of experience in building autonomous vehicle solutions, particularly. So a little bit of a collage here, kind of a subset of the past projects that we have been involved in, the co-founders and some of our technical team members. So as you can see, we've dealt with various flavors of autonomy: single vehicle, multi-vehicle, on this planet, on Mars, indoors, outdoors. So that kind of gave us, how to say, almost like it calibrated us in a sense, in terms of understanding how difficult this problem is, and also gave us the option to kind of go after any potential autonomy application within this realm, within this universe. But from the very beginning, we have been extremely deliberate in kind of picking our battles, if you will, and chasing after a very focused problem. So back then, pretty much everyone else was chasing after the robotaxi problem. It's a very cool application, but from a technology difficulty perspective, it's actually the holy grail of autonomous driving. And when you look at it from a business perspective, it is a nice convenience, but it is not a true painkiller. So we actually turned our ears to the industry, and there were really strong distress signals coming from the trucking industry, even back then, and we kind of live it nowadays. So as you may know, more than 70% of the freight in the US is actually moved by trucks. However, there is this constant increase in demand, but there is really constrained and diminishing almost supply, because the trucking industry is having a hard time finding qualified drivers and retaining them. Over-the-road trucking especially is a very demanding job, and people have to stay away from their homes for really long durations, which is not a very desired situation. And of course, there are all those hours of service-related stretches, and as a result, there are some accidents, and that with that comes higher insurance premiums, et cetera, et cetera. So it's almost like a negative feedback loop that the trucking industry is suffering from. So it was very clear that this would be the application area or the immediate application area for any kind of autonomy flavor to relieve some of this pain. But again, it would not be possible by just going into our corners as technologists and building the autonomous vehicle technology and hoping that it would be magically integrated into the industry. So that's why we devised these 3 pillars for our successful deployment. The first pillar is, of course, the autonomous vehicle technology. That's what we are building. And the second one is what we call autonomous relay network. It's essentially an analysis framework where we look at on which segments we can actually safely and profitably deploy our autonomous vehicle solutions. And the third one is how do we integrate all of that into the existing industry workflow that we call the digital transportation system. And our approach to autonomy is also a little different, and very deliberately so, because we are aware of the fact that this is an incredibly difficult problem. By this, I mean level 4 solo driverless operation. We decided to take a phased step-by-step approach, starting with the human-guided autonomy concept. In the human-guided autonomy concept, we have actually two product flavors. The first one is what we call the autonomous relay convoy. It is a two-truck, two-driver concept, and the two drivers existing in the trucks also very conveniently and seamlessly handle a lot of peripheral problems like handling the pre-trip inspections, paperwork, securing the loads, and also driving the vehicles through the surface streets, the urban segments, which are the most sophisticated segments for an autonomy solution. And once the vehicles are on the freeway, the driver of the follower vehicle presses a button on the dash, engages autonomy, and from then on, they don't actually have to sit on the driver's seat. They can clock out, go back to the sleeper berth, and start taking their mandated rest as their cargo is moving. And the convoy moves in this configuration for the duration of a shift, let's say 7 or 8 hours. And after that, the follower vehicle's driver wakes up, all well rested, goes back to the driver's seat, assumes control of the vehicle, coordinates with the other driver, goes and passes the former leader and becomes a new leader. And the new follower, the former leader, repeats the operation, presses a button on the dash, engages autonomy, goes back to the sleeper berth, and start taking their mandated rest. So that way, we have one human actively commanding two trucks and delivering twice as much cargo, twice as far with half the cost. So that's the concept there. And the second phase is still a convoy concept, a human-guided convoy concept, but this time we don't have any drivers in the second cab. It is a completely unmanned system, and this one is designed for shorter routes. And with the deployment of this convoy concepts or the human-guided autonomy concepts, we believe that we will have exposure to a lot of very interesting real-world cases while we are actually operating safely and profitably. So the data collected and that experience kind of gained throughout those deployments will pave the way for solo driverless operations for us in phases 3 and 4, where we will be tackling hub-to-hub and dog-to-dog solo driverless operation. When we look at the overall cost savings or the value propositions of these different flavors of autonomy, even with the autonomous relay convoy, we are actually capturing 65% of the overall value proposition of a solo driverless vehicle. So in solo driverless case, we are looking at a maximum of 45% cost savings, and autonomous relay convoy achieves 30% of it. So again, as for how to deploy or where to deploy this technology or these flavors of technologies, we looked at the freight network very closely. We looked at the U.S. map, how the freight moves across the U.S., and identified 25 interstates that were actually yielding more than 88% of the daily freight flow. So we decided to focus our attention there. We further divided those 25 interstates into 68 segments. And when we were doing that kind of segmentation and optimization, we looked for maximum asset utilization, maximum efficiency, profitability as well. Not all lanes are created equal, and also sustainability. So with this kind of flexible framework, we can actually combine multiple segments or divide them further to suit the use cases of different customers. So this is the overall autonomous relay network framework that our autonomous vehicles will be running on. And again, even though I mentioned that step-by-step kind of progression from autonomous relay convoy to drone follower to solo hub-to-hub and dock-to-dock operations, it does not mean that we will be retiring a solution once we advance in those phases. So we won't be retiring autonomous relay convoy when we switch to drone follower, or we won't be retiring convoy concepts when we switch to solo driverless operation. So at some point, we envision that all of our 4 autonomy flavors will be simultaneously deployed and working throughout the nation, because they each have a different use case and different application conditions. So a closer look at our autonomous relay convoy product, the first product. This animated explainer actually shows how the operation takes place. So the first vehicle is, as I mentioned, human-driven, and the second one follows it autonomously. They are linked through vehicle-to-vehicle communication links, and they can follow each other relatively closely, hence reducing air drag around both vehicles and saving a significant amount of fuel. And this model, we are increasing existing driver productivity by 2 times, increasing equipment utilization almost by 130%, because currently only 30% of the time the vehicles are doing something useful. Otherwise, they are either parked or kind of idling, waiting for the loads and all that stuff. So with our overall approach to load planning and route optimization and autonomous vehicle technology combined, we can increase that utilization to about 20 hours a day. And last but not least, because of the fuel savings, we are reducing the carbon footprint significantly. We anticipate each of our tractors, when operating in convoy mode, and also optimize for minimal wait time, minimal idling time, etc., will reduce carbon dioxide emission by 60 metric tons per year per tractor. And again, from an ESG perspective, we see autonomous relay convoy as the fastest path to net zero emissions. And also, with this approach, we are still keeping humans in the loop, hence addressing driver shortage problem, essentially utilizing the existing workforce and guiding them with the transition to the future technologies, kind of a gradual transition there, as well as improving their quality of lives. And also, given that we still have human in the loop, we believe that it is a safer approach with the superior cognitive capabilities of humans compared to robots. We will be increasing situational awareness and overall safety of our system. So apparently this phased approach, this realistic approach, and the holistic approach to autonomy by Locomation resonated very well in the industry. And as a result, Locomation happened to be the first autonomous vehicle developer to have signed commercial contracts with 2 customers. So our first customer is Wilson Logistics, and we are looking to deploy more than 1,100 trucks, essentially retrofit more than 1,100 of their trucks with our technology, autonomous relay convoy technology, and start deploying by the end of 2022. And our second customer is a local Pittsburgh-based carrier named PGT Trucking, and they are committing to 1,000 trucks initially. So this is super exciting, of course. Also, making us very anxious as well, because we have relatively tight timelines that we are looking at. Of course, it takes a village to make this technology or this deployment a reality. So being aware of that, we are forming very strong partnerships and working closely with industry leaders when it comes to retrofitting our trucks with the relevant and autonomy-ready hardware. So recently we announced our partnerships with ZF and Cummins for autonomous operation ready steering and powertrain solutions. So we are jointly developing and testing those solutions. We are working closely with Bendix on braking solutions as well. And a few months back, we announced our partnership with Rush Enterprises and Custom Vehicle Solutions. So they are going to be our post-delivery installation and maintenance partners. Very, very recently, we announced our partnership with Aon. They will be managing our risk. And of course, we are working very closely with regulatory agencies to make sure that the regulation landscape is ready for this deployment. Of course, safety is a big part of this equation. We are working with experts in the safety domain to craft our safety case. It's essentially a structured evidence-based argument that the autonomous relay convoy system is acceptably safe. And the framework, of course, pulls from best practices in the industry and the relevant safety standards like ISO 26262, functional safety standard, ISO PAS 21448, safety of intended functionality, and also cybersecurity related standards, as well as the more recent UL 4600 standards and military grade 882E kind of standards. So, but when we distill everything into a few bullet points, the framework can be represented as a very strong safety culture that has to be at the essential foundation of everything. You need to have a really strong safety culture to make this technology a reality. And after that comes, of course, engineering things right by following proper systems engineering processes and verification and validation methods. We need to make sure that whatever we design is actually manufactured right. So there's going to be lots of quality control processes in place, and we'll be partnering with certain manufacturers on that front as well. Once things are manufactured and deployed, we need to make sure that it is actually operated right. So we are in the process of preparing lots of training materials for the prospective drivers of this technology, or the pilots, I should say. And once deployed and we start gathering field monitoring data, relevant telematics and such, we need to have a way to improve it right, because it is going to be a false statement if I said the first time deployment is going to be absolutely perfect. So we need to have mechanisms to improve our systems right based on the feedback we get from the field. And for the regulatory strategy, we are working very closely with each of the 50 states and making sure that we comply with all state regulations, including all the permitting and reporting requirements. And there doesn't seem to be any federal barriers to deployment of the ARC system at the moment. We are working closely with FMCSA on that and looking to hear back from them soon. And on top of that, we are also working closely with US DOT and state authorities, essentially in shaping regulations and laws applicable to commercial deployment of this technology. So we are engaged in various initiatives like the US DOT Voices Initiative, the Automated Driving System Demonstration Grants, and 21st Century Truck Partnership Program. And also we are participating in kind of educational demonstrations like the smart belt deployment that we performed from Pittsburgh to Detroit. So all these actually provide us with feedback and provide the regulatory agencies with the necessary feedback to craft their narratives and essentially prepare the landscape for this technology. This video shows, after all these preps, of course, our first pilot deployment with Wilson Logistics along I-84. And it was performed in July of 2020. So that's a 420-mile segment that we traversed back and forth for 2 weeks, accumulated about 3,400 miles, and more than 1,500 of those were actually autonomous. And we were extremely cautious when it comes to the operation of this technology, because back then it was even more experimental, and that's why we were manually disengaging the system whenever there was a vehicle on the shoulder or whenever we were going through work zones. Now we can handle majority of those situations without having to disengage, but back then we were just extremely cautious. This segment shows a 50-plus mile autonomous kind of driving experience. The reason it is capped with 50 miles was that we did not want our safety operators to supervise that experimental system for more than an hour, because it puts a lot of cognitive load on the operators and the test engineers. That's why every hour we would just manually disengage and swap places with the second truck, so that the second truck's driver could experiment with the autonomy. But this was a very successful pilot, and this was pretty much what initiated our contract with Wilson Logistics. A little bit of a closer look at our hardware outfit. This picture actually shows our new generation prototype trucks. And the most salient feature is our sensor pods assembled on the mirrors. So our perception sensors include cameras, LiDARs, and radars, and that we fuse all together to essentially make them work in various different conditions, because each of those sensors have their strengths and weaknesses, and we want to make sure that they actually complement each other very nicely. Aside from sensing, we also have vehicle-to-vehicle communication components, antennas on the mirrors, that are not something common that you would see on other solo autonomous vehicles. Since we are operating a convoy, our vehicles have to talk to each other. And when it comes to the by-wire interface, as I mentioned, we have partnerships with ZF and Cummins in essentially developing and testing autonomy-ready or autonomous operation-ready powertrain and steering solutions. And on the computing end, one of our partners is NVIDIA. We are still kind of considering potentially making their Orin architecture part of our, or system on a chip solutions, part of our computing stack. But again, when it comes to NVIDIA and GPUs and such, the natural understanding of people is that, well, it is for deep learning. But I must say that our existing code base does not have a single line of code that pertains to deep learning. We are not utilizing that modality at the moment because we don't want to have any kind of black box systems in this kind of a safety critical application. Very broad look at our overall autonomy architecture. I'm sure many of you are familiar with this general architecture. It does not look very different than a solo driverless vehicle's architecture. Essentially, the perception subsystem processes the incoming sensor data, and the detected objects and features of interest are then passed to our world modeling system, where we keep track of how things are moving around us, what are we predicting about their behaviors, etc. And the planning and control subsystem looks into that world model in deciding what to do next. And a bunch of trajectories in the form of speed and steering trajectories come out of it and go into our by-wire kit interface. And the by-wire kit interface translates all those trajectories into the languages that individual control units would understand from a steering, throttle, and brake perspective. And one, of course, distinct part of our system is a big HMI subsystem sitting there, because we are still talking about a human-centric approach, and as a result, we need human-machine interfaces that does not necessarily exist in solo driverless vehicles. And on top of that, of course, we have a communication subsystem to establish communication between the vehicles. And one thing that is missing from here is an explicit global localization module. Our solution does not rely on global localization. We are not building and maintaining HD maps as a result. Our system operates in relative coordinate frames. When it comes to testing and validation, the first step is actually simulation. And everyone likes to show how things are working in simulation when conditions are really good. But we actually use simulation for a different purpose, to understand the limitations of our system. So that's why we are utilizing physics-based, realistic physics-based simulation environments to model our vehicle dynamics and see where they actually break. So for instance, the upper left video shows under what kind of condition, what kind of load and speed conditions, a slight steering mishap actually causes. In the best case, it's a lane departure. In the worst case, it's a rollover. So we need to understand those kind of conditions and limitations to make sure that our safety rigor is in place and we build the system properly before we actually deploy the code on the physical vehicles. Coordinated motion in general is kind of the crux, the core of our technology. Those vehicles are synchronized in their motions on the longitudinal and lateral axes. And these three videos actually show that behavior. On the left side, you see kind of the introspection from the eye of the robot, how it reconstructs the path of its leader and how it actually stays on that path while also maintaining a tight gap between the two vehicles. So if you also pay attention to the cross-track error indicator in the laser point cloud view, you will see that once the vehicle is actually on the path, it can actually maintain that path with single-digit centimeter accuracies. And on the upper right, we see the drone footage of that behavior. Essentially, the vehicles seamlessly and simultaneously changing lanes back and forth. And the bottom right video shows the vehicles coming to a stop simultaneously. So that's achieved by having vehicle-to-vehicle communication between the two vehicles, so that whenever the leader truck applies brakes, even before the vehicle physically starts decelerating, the follower knows about that behavior and starts applying the same kind of deceleration profile. We don't only test in really good conditions, but also relatively harsh conditions as well. This is another view from our tests at the Transportation Research Center. And again, I cannot claim that we are done. It would be a kind of a stretch to say that we still have a long way to go in terms of our testing and such, but it is important to make sure that we are testing in all those harsh conditions as well, not just in sunshine. So again, we have a long way to go, but we are taking very deliberate and well-planned steps along a proper product development life cycle. And with that kind of rigor, we hope to be able to deploy our systems commercially by the end of next year. And keep an eye out for our upcoming announcements on that. And thank you very much for attending this presentation. I hope it was an interesting and useful one for you.
Thanks a lot there, Tekin. Just for everyone in the audience, please keep entering your questions into the Q&A chat. We have quite a few in here, and we'll get to them here in a second. But thank you once again, Tekin, for taking time here and going over Locomation and all the good work that you all are doing out in Pittsburgh, working towards advancing automated trucking. Being the moderator, I'm going to take my own prerogative here and ask the first question. Locomation's one of the few AV developers and from a trucking standpoint that's actually doing work right now in the northern states versus focusing on the Sun Belt or the I-10 corridor. Do you see any benefits in operating here in the northern states versus just looking towards the southern states to begin?
I mean, first of all, that PA is our home state, so it is a lot more convenient. But also, it provides us with very kind of challenging natural testing conditions when it comes to especially the weather. we have quite a few months of harsh winter. So that's very convenient. And also, it's a nice, how to say, like a petri dish for us, because we have very close relationships with you guys. So we are sharing very openly our observations and experiences with you, and you are sharing your recommendations with us. So from that kind of high bandwidth communication perspective, it is a big advantage for us. But I think, again, all these conditions considered, testing here in the northern states is a big advantage. Again, at the end of the day, these trucks are built for really harsh conditions, and they need to be tested for that. So it's the test as you fly and fly as you test kind of principle.
Great. So as you do your testing here, what state-to-state differences in platooning laws and regulations have you encountered as you move across the country?
Yeah, I think the major difference is with the arbitrary following distance related parts. So some states allow arbitrary following distances as long as the vehicles are connected. Some states don't. So we have to actually be careful with that, because in our case, we are looking at very close following distances between the two trucks. And unless they are tethered electronically and react to each other's behaviors in milliseconds, it is not human safe, if you will. So that's why I think that is the biggest difference that we see. And of course, there are other kind of details as well. Some states allow just testing but not deployment, so we have to work through that as well. And yeah, the regulatory landscape, state by state regulatory landscape, is a bit of a patchwork that we have to navigate very nicely. So there's really no unified framework that ties everything together. So everyone has their own combinations of rules and regulations. But again, we have a 50-state policy that is being maintained and tracked by our VP of Policy and Strategy, Finch Fulton, and we make sure that we are compliant with wherever we are testing at.
You mentioned your 50-state policy. Now, are there any plans or considerations to look to the north or to the south, into Canada or Mexico, respectively? Or is your initial plan to just stay within the United States?
Initially, we are just focusing in the United States, because even the United States kind of is stretching us a bit too thin, having to keep track of all those regulations and such. And that's why before we master this geography, we don't want to expand our operations to Canada or Mexico or Europe, for that matter. We just want to make sure that we stay laser focused. I think it's kind of a general theme of our approach. Maybe I forgot to mention during the rest of the presentation. We essentially try to right-size everything. Right-size the problem, right-size the team, right-size the operational design domain, application area, so that we can actually time box things and solve this problem instead of leaving a lot of the fronts open-ended.
Yeah, there's a lot of us here on the call who struggle also with trying to keep up with what every state is doing with regards to automation. So you're not alone there. We got some feedback here about your autonomous relay network. And are there any expectations from state DOTs or roadway infrastructure owner operators relative to the autonomous relay network? Or is this something that you're just mapping and you're going with, or is there things that they're looking for that a state DOT can do?
So that's a great question. We are trying to make the system as infrastructure independent as possible, especially when we are planning the routes for this deployment. We are looking at kind of continuous routes that do not go through, I don't know, like toll booths and all those interaction points, if you will. But regardless of what we want and what we optimize for, there is going to be some form of interaction with the law enforcement, with other kind of inspection units, etc., way stations, and just random pull over and kind of get checked kind of inspections. So the human in the loop in our system actually handles all those things very, very neatly. And moving forward, one thing we can, of course, collaborate with the DOTs would be expanding our kind of communication from just vehicle to vehicle to infrastructure as well. And kind of as we are kind of passing by, let's say, a way station or a toll booth, we will be able to say that, okay, these are kind of connected vehicles, autonomous vehicles, and here is the paperwork that you need to see, etc. So everything can be done electronically to kind of streamline that process. Of course, other aspects would be making sure that the infrastructure, overall infrastructure, is actually ready for this kind of a use case, where we are looking at 2 trucks initially, fully loaded, following each other very closely, potentially putting a lot of stress on the underlying asphalt surface in terms of, again, like pure load as well as vibration characteristics. We want to make sure that the overpasses we go on or the bridges we go on would be actually durable for that kind of an operation. So that's another venue that we can certainly collaborate.
So we received a question here: if something happens to the first truck where it starts to, say, lose control while traveling due to, say, slick roadways or other conditions, the second truck when it's in the autonomous relay, is there technology to disallow the truck to do the swerve so it's not a direct follow? How does that work in those types of situations?
Yeah, that's a great question as well. So we have a very strong human factors team as well, and as part of their day-to-day jobs, they are looking into communicating intention between the 2 trucks as well. So our follower truck actually has 2 different lateral control modes. One is mimicking the leader as a kind of almost like a little duckling, and the other one is centering the lane lines whenever they are present and whenever our perception of those lane lines is actually high confidence. So based on the communicated intention from the lead driver as well in terms of their lane change maneuvers or swerve maneuvers, etc., we can decide whether to actually blindly follow them or kind of employ our own intelligence, try to stay in between the lane lines and kind of stay away from all the adjacent traffic. So in case something goes wrong with the lead truck, for instance, I don't know, it is possible for the lead driver to have a stroke or a heart attack. That's not unseen. In that case, that lane departure maneuver is likely going to be an unintentional one. Hence, no intention will be communicated to the follower vehicle, and that is going to be a signal for the follower vehicle to actually put itself in a minimal risk condition situation. So not stop blindly following the leader and do something about that situation. Either try to find a spot on the shoulder to pull over and come to a safe stop, or take the nearest exit and come to a safe stop, etc. So we have a triage of kind of emergency maneuvers that we consider at any given time, in addition to our nominal plan. So whatever emergency maneuver is most suitable for that particular case will be picked by the follower vehicle and essentially executed autonomously to bring the vehicle to a minimal risk condition.
So this technology offers a lot of benefits, and of course, everyone about the safety and mobility, but then also, of course, there's the environmental. And you touched on the fuel savings, but also, because you're putting 2 trucks out there, which potentially, with driver shortages and things like that in the future, you might not necessarily had, you could potentially increase CO2 emissions. So kind of the only way to get around that is going towards electrification. Is that something you are looking at right now, knowing that what you're doing right now is more on the diesel combustion engines, but are you also at the same time looking towards electrification?
Yeah, so again, our go-to-market strategy is to start with an aftermarket kit and essentially integrate our autonomy kit in form of hardware and software onto existing trucks. So we have certain like abstraction layers and interfaces at a certain level. We actually don't care whether the underlying powertrain is internal combustion engine based or, I don't know, fuel cell based or electric based. As long as we maintain that interface, we can actually control any kind of underlying vehicle. So it is certainly on our roadmap to make this technology available for alternative fuel vehicles whenever they become mainstream and available. And we have conversations around that with the relevant parties as well. But again, at the engineering end, we are trying to architect our system to be as agnostic and future compatible as possible.
Now, you mentioned that you're having conversations with FMCSA right now, and I'm assuming one of those conversations is with regards to electronic logs and hours of service. You know, do you have a sense on how that will actually play out in the future with this technology, or is this still an uncertainty that you're looking towards?
So yeah, I mean, you are pretty much right there. So hours of service and ELD related topics are definitely among the discussion points. So right now, the definition of a driver is either a human or a machine. And in our system, we are essentially looking at almost like a distributed application of existing team driving concept, where one driver drives the vehicle and the second driver actually sleeps in the sleeper berth. So that kind of application already conforms to the existing hours of service regulations as well. In our case, in that distributed configuration, the two vehicles, the primary driver of the follower vehicle is going to be a machine, while the secondary driver, or the human driver, is actually taking their rest. And the overall driver of the entire convoy is still going to be a human, while the second driver is kind of resting. So we believe that we are already compliant with the existing definitions when it comes to what qualifies as a driver and how the hours of service works in case of team driving. But again, this is an active discussion going on with FMCSA, and we are waiting on their final decision.
Certainly. So I'm sure this is a question you get a lot here, but how would the trucks react if a third vehicle were to place itself between two trucks?
Another great question. So our intended following gap is relatively tight, even though the videos kind of show relatively large following gaps, especially the Wilson Logistics demonstration, because back then, again, the vehicles were even more experimental, and we wanted to make sure that we mostly rely on human reaction times. That's why we started like a 2-second following time gap configuration. But in the later videos I showed, we actually reduced that to almost half a second following gap. And that's what we intend to maintain for commercial deployment as well. And at highway speeds, that corresponds to less than 15 meters of distance gap between the two vehicles. But of course, it's not going to be like a constant number. It's going to be modulated based on a lot of factors like road conditions, load differences, uphill, downhill, the topology. And according to some public studies and our observations as well around platooning, when the following gap is below 20 meters, the number of cut-ins virtually approach to zero. And even if they occur like in a very transitive kind of manner. So if someone comes from the left lane, occupies the gap for a couple seconds and departs to the right lane and takes an exit, or someone comes from a merge ramp, occupies the gap for a couple seconds and switches to the left lane and passes the convoy. So, and we also have statistics around overall lane change, like average lane change durations and such, which is about 5 to 6 seconds. So the idea is, even after all that tight gaps and such, even if someone manages to squeeze in, we will be observing that vehicle for the duration of an average lane change maneuver. If they are not leaving during that period, we will be simultaneously slowing down the entire convoy. First, to encourage them to leave, and second, in case of an impact, we make sure that the impact is actually reduced. So opening the gap is not a really good strategy in our opinion, because when you open the gap, you essentially invite other intruders to the gap, and before we know it, we will have several vehicles between our autonomous follower and human-driven leader, and our autonomous follower will be converted to a solo driverless vehicle, which is not our concept of operation or the case that we are preparing the system for. That's why we need to make sure that we prevent that from happening.
So I know we get a couple questions in here, and I think a lot of it's also around this uniqueness of you have a business model that's incorporating connectivity and automation together, where a lot of companies now are just looking at to separate the two. So one of the questions we got here is when the two trucks are connected, is the second truck pulling any type of sensory data from the first truck, as well as using its own sensors to determine speed and vehicle positioning, spacing?
Yeah, great question. So the vehicle-to-vehicle communication link is used for two main purposes. One is to communicate the vehicle states between two vehicles. By vehicle state, I mean their current speed, acceleration, and speed acceleration, and I don't know, transmission schedules, steering angles, and all that stuff. So by transmitting those control signals, essentially, we can apply those signals in a feed-forward fashion to the follower vehicle's control loops. So it's almost like before you observe your lead accelerating or decelerating, you know what they are about to do, and you kind of take that into consideration when you are planning your own trajectory. So that is one use case, and the other use case is our vehicles are actually identical from a hardware and software perspective, and that's what enables them to swap the leader and follower roles. And that's also what enables us to run our autonomy stack on both vehicles simultaneously. The autonomy stack actually actively controlling the follower vehicle while kind of providing even richer situational awareness to the lead vehicle operator. And as part of that, the vehicles will be doing their own sensing using their own sensors and exchanging that world model information essentially between the two to combine them and consolidate them into a coherent single world model around the entire convoy instead of like two individual models. This is a unified model showing what is going on around the entire convoy. And a particular representation of that will be reflected on a display in front of the lead vehicle's operator, so that when they look at it, they will be able to see whether there are any vehicles on adjacent lanes to the follower, whether it's safe to change lanes for both vehicles, etc., whether there's a vehicle cut-in situation. So that kind of situational awareness creation will be part of the use cases for vehicle-to-vehicle communication.
Thank you. Unfortunately, here I know we still have a bunch of questions, and I know I have a whole list of questions here we could ask. I feel like we could be sitting here for a couple hours just going back and forth on this. But unfortunately, we are out of time. I'm assuming you had your contact information there on the last slide. If anyone online has any questions or interest, I'm assuming they can just reach out to you, reach out to the team at Locomation. I know from our interactions, you guys are always super open, super helpful, and we very much appreciate that collaboration, which we think is necessary to advance this technology safely. So with that, I want to thank you. I know in a live environment, we would typically encourage the audience to clap. I think we have a clap emoji, so feel free to hit that if you're there. I see some people hitting it now, so we appreciate you taking time out. So thank you once again for your insights, and thank you all for your questions that you submitted to give this thought-provoking discussion. We will now exit presentation mode and go back to the conference room where you have about a 15-minute break here to chat with other attendees. Feel free to network. That's one of the great things about this platform, even in a virtual environment. When you're ready, then move to the first breakout session. Please go to the directory at the top left of your screen and open the drop-down to select the breakout session that you want to go to next. The breakout sessions that are occurring are environmental, and the pathway to deployment session, which I mentioned earlier, which is sponsored. Once you're ready to head to the breakout sessions, please open the directory, choose that session you would like to attend, and thank you all, and we hope to see you at the breakout session. So thank you, Tekin, and thank you, everyone.
Thank you very much.